Okay. Distinguished participants, ladies and gentlemen, good morning. And on behalf of CESRIC, welcome to today's training course on market surveillance and inspection of personal protective equipment. My name is Murat Sevgi. I will be today's moderator for this training course. Today's training course will start with personal protective equipment categorization and PPE product groups, the first group. The session will be brought to you by Ms. Begim Silsüpür, Occupational Safety and Health Expert and Market Surveillance Inspector under the Ministry of Labor and Social Security of the Republic of Turkey. Without further ado, Ms. Begim Silsüpür, thank you for your kind collaborations for today's training courses. The floor is yours. Thank you very much.
Thank you. Good morning to all dear participants. I will begin my presentation. Let me share my presentation.
We can see it clearly, madam. You may
Okay.
proceed.
To begin by introducing myself, my name is Gökçe Begüm Silsüpür. I'm an occupational health and safety expert in the Ministry of Labor and Social Security. I have been working for the General Directorate of the Occupational Health and Safety since 2011. I'm a market surveillance inspector. I have been working at the Department of Market Surveillance and Inspection since 2015. I'm an electrical and electronics engineer at the same time. Today, I would like to inform you about personal protective equipment groups 1. In this presentation, firstly, I will express what the PPE is. Yesterday, my colleagues defined and gave information about this issue. I would like to repeat some important points. Secondly, I will cover the types, categorization, and general features of appropriate and safe PPEs. After that, I will explain respiratory protectors and foot and leg protectors. Let's start with the first part. What is PPE? I want to repeat again. Personal protective equipment is designed and manufactured to be worn and held by individuals to protect against one or more health and safety risks. All PPEs should be suitable for preventing the relevant risk without creating any additional hazards. And all PPEs should be compatible with the existing conditions in the workplace. All PPEs should meet the ergonomic requirements and health condition of the user. And all PPEs should be fit perfectly when necessary adjustments are made and should include the appropriate CE mark and a Turkish user manual. Now let's take a look at this. There are many types of PPEs, which namely head protectors such as helmets, hearing protectors such as earplug, eye protectors such as safety glasses, respiratory system protectors such as dust masks, hand protection equipment such as glove, foot protectors such as safety shoes, protective clothing such as high visibility vest, and protective equipment against falls from height such as full body harness. And finally, drowning prevention equipment such as life jackets. I will explain to you about respiratory protectors and foot and leg protectors. After that, Mrs. Güler Çoban will explain hand-arm protectors and hearing protectors. Mr. Ömer Sert will give a presentation on protective clothing and drowning protectors. And finally, Mr. Erkan Serdar Serter will give you information about head protectors, fall protection equipment, eye and face protectors. And now I want to explain categorization of PPEs. It is important which risks the personal protective equipment provides protection against. PPEs are categorized according to the level of risks they protect against. As you can see in the slide, PPEs are divided into 3 groups according to the categorization. Now you see the categorizations. For category 1, I can say that they are simple structured PPEs. For example, caps used for scalp protection, footwear, etc. For category 3, I can say they are complex structured PPEs. For example, respiratory protectors, insulating shoes, safety belts. And for category 2, I can say all PPs except category 1 and 2, 1 and 3, sorry. They are, for example, high visibility protective clothes, helmets, etc. For category 1, I can say that PP of a simple structure they are, that provides protection against low level of risks that the designer considers to be accessible by the user himself, that occur gradually and are detectable in a timely manner. For example, superficial mechanical injuries, contact with weakly effective cleaning agents, or prolonged contact with water, contact with hot surfaces not exceeding 50 centigrade degree, and damage to the eyes due to exposure to sunlight, and go on. The category 3 is all PPs other than category 1 and 3. For category 3, I can say that they are PPE with a complex structure that provides protection against risks that may arise suddenly in situations where the user is not expected to notice them in time, and against risks that may pose a life-threatening danger and cause serious or irreversible damage to the health. The products cover risks that result in very serious consequences, such as death or irreversible damage to the health. For category 3, there are risks, substances and mixtures hazards to health, oxygen deficient environments, ionizing radiation, high temperature environments whose effects are comparable to air at a minimum temperature of 100 centigrade degree, low temperature environments whose effects are comparable to air at a temperature of minus 50 centigrade degree or levels or lower, falls from heights, drowning, and so on. Now I want to explain about general features of appropriate and safe PPEs. The most important issue in selecting the PPE to be used is knowing whether the PPE is produced in accordance with the technical regulations, the basic health and safety requirements that products must meet, and how these requirements will be met are specified in the standards. Products manufactured in accordance with the standards are assumed to meet basic health and safety requirements. Standardization and conformity assessment are important elements of the market surveillance of technical products. All PPE equipment must bear the CE mark. PPE must provide adequate protection against all risks encountered during its intended use. PPE must be designed and manufactured to protect the user at the highest possible level when performing hazardous work. PPE shouldn't cause hazards or distributing factors that may arise from its structure. The manufacturer must provide a user manual in official language. In our country, we look for a Turkish user manual. The manufacturer of the product must also provide name and address of the manufacturer or authorized representative, information on storage, cleaning, use, maintenance, performance results recorded in technical tests performed, characteristics of accessories, appropriate protection classes for different risk levels, month, year, or period of the life or expiry date, regulations and harmonized legislation, and title, address, and identification number of the notified body, and so on. For PPE selection, risk assessment, environmental and personal exposure measurement results should be taken into account. The work being done is very important. If PPE are not ergonomic, employees will not use them. Because PPE provide protection as long as they are worn. When selecting the size of PPE, the physical characteristics and personal choices of the employee should be taken into account. For example, when purchasing ear protection for the workplace, the employee should be asked whether they prefer ear muff type or foam type ear protectors. Now I would like to provide you with information about respiratory protectors. Medical face masks are used during surgical procedures and in other medical environments. Those medical face masks are not designed to protect the wearer from bacteria or viruses. Instead, they are intended to stop infectious agents potentially exhaled by the wearer from dispersing into the environment. These masks are not PPE. The masks on the right are in the PPE category. Equipment such as gas, dust, and radioactive dust filter masks, air supplied respiratory devices, and respiratory devices with removable welding masks can be given as examples of PPE. Respiratory protectors are classified under category 3. All respiratory protectors designed and manufactured to protect against solid aerosols, liquid aerosols, and gases. All respiratory protectors designed and manufactured to provide complete isolation from the atmosphere. And all respiratory protectors designed and manufactured for diving purposes fall under this category 3. Now I want to talk about respiratory protectors species. Respiratory protective equipment must be used by workers in environments where there are chemical or particle hazards such as gas, dust, vapor, or spray, or where the oxygen level in the air falls below 19.5%. Respiratory devices are divided into two main groups. First one is air-dependent respirators. These rely on the surrounding atmosphere and filter the air from the environment for the worker to breathe, such as dust masks. And the other type is air-independent respirators. These provide air to the worker independently of the surrounding atmosphere, such as supplied air respirators. For air-dependent respirators, I can say the respiratory protectors that are classified as dependent on the ambient atmosphere, which filter the air from the environment for the worker. The types are full face masks, half face masks, filters to be used with mouthpiece devices and self-rescue devices, etc. A full face mask protects the entire face, while half face masks or filters used with mouthpiece devices protect the respiratory parts of the face. The filters contained in these respiratory protectors may provide protection against particles, gases, vapors. However, these types of respiratory protectors don't provide protection against oxygen deficiency. Use of dust masks in dusty environments. Dust masks are used to protect the respiratory system from dust in the workplace environment. Dust masks must be produced in according with the TS/AN 149 standard. Based on personal exposure measurements taken in the working environment, the following types of masks should be used depending on the dust concentration relative to the limit value. FFP for areas with up to 4 times the limit value, FFP2 types for areas with up to 12 times the limit value, FFP3 masks for areas with up to 50 times the limit value. We could calculate the nominal protection factor according to the equation, and we decide which masks to use. Using masks in gas environments. Another risk is the presence of asphyxiating or toxic gases in the environment. Gas masks are used to protect the respiratory system from harmful gases. In case of this, we should use gas masks. We shouldn't use a dust mask. Gas masks must be manufactured in accordance with the TS/AN 136 and TS/AN 140 standards. You can see the visualization. For half face mask, I can say they protect against inhaling dangerous gases depending on the gas levels in the environment. For full face masks, I can say that in addition to facilitating breathing, it protects the eyes and the skin. Gas masks generally consist of filters that prevent unwanted air from entering and ensure that The wearer breathes clean air with a design that fits the face perfectly. Replaceable cartridges prevent hazardous gases from entering the mask. When these cartridges become contaminated with chemicals or gases, they must be replaced immediately. Filters should be selected according to the type of gas exposure. The related standards for respiratory protectors are shown in the table. There is a TSEN 136 standard. This is for full face masks. The TSEN 137 standard is for self-contained open circuit compressed air breathing apparatus. And the TSEN 140 standard is for health masks, excluding escape and diving devices. The TSEN 149 standard is for filtering half masks to protect against particles and so on. You can see that this particle filtering half face mask standard is shown here, and the visualizations are here. A mask could has a valve or not. Its shape could be conical or foldable. We can determine whether the mask is reusable or not reusable by checking the labeling on it. If we say this sign, we could understand that the masks that pass the Dolomite dust test and the mask provide protection for clogging with Dolomite powder. The markings and information regarding the respiratory protective equipments there are. The manufacturer must specify the essential protective features of the equipment, the duration of protection, or the expiration date of effective protection. Proper usage and storage of the masks are as crucial as selecting the appropriate masks to ensure adequate protection. In this regard, employees must be provided with the necessary training and information. You can see the brand model of the masks. The manufacturer should state a brand model information, CE mark, a 4-digit identification number of notified body, standard number, manufacturer's name or logo, year of manufacture, and the protection class is important. Gas masks provides protection against gases and vapors, and you can see the relevant standards. Filters are color-coded to assist in selection and monitoring of workers. Particle filters are white and have blue or red markings based on their performance levels. The most commonly used gas filter is AB filter. Gas, vapor, and combined filters have color-coded bands according to the performance color coding specified in the European standard. According to the TSEN 14,387 standard, the meanings of the letters in the protection categories are shown in the table. For example, the AX and A code, for AX and A code, the color is brown, and the meaning is that gases and vapors form organic compounds with a boiling point smaller than 65 centigrade degree. And for B code, which has a gray color, it is for inorganic gases and vapors such as chlorine, hydrogen sulfate. For A code with yellow color, this is for sulfur dioxide, hydrogen chloride, etc. For K code, we should use green color with ammonia. For HG code, the color is red, and it means is for mercury vapor, and so on. These are gas mask filters. Gas masks filters standard is TSEN 14,387 plus A1. The protection levels could be 1, 2, or 3. The storage durations of gas filters are type A. For type A, it's for 5 years. For type B, it's for 4 years. For types E, K, and HG, it is for 3 years. And based on gas holding capacity, these are the types of the filters. Type 1 is for low capacity filters. Type 2 is for medium capacity filters. Type 3 is high capacity filters. On the sealant band is opened, once the sealant band is opened, even if the filter is not used, it must be replaced with a new one. Air-independent respiratory protectors. These types of respiratory protectors are those in which a clean air supply to the worker is essential instead of relying on the ambient air. They consist of a face protection component and a breathable gas system. They are also classified as closed-circuit breathing apparatus. Now we come to the last part of the presentation. I want to give information about foot and leg protectors. In the work environment, there may be a need to use personal protective equipment to protect the feet and legs. Some stations, workers should use foot protection equipment. I can say when there is a risk of heavy objects falling on the feet, when sharp objects such as nails or metal pieces are present in the work environment, in work involving molten metals, in environments with hot, wet, or slippery surfaces, then electrical hazards are present. All equipment and relevant accessories specifically designed and manufactured to protect the feet and legs and prevent slipping are in this protector group, such as shoes, boots, safety boots, and shoes, knee protectors, and gaiters fall under this category. When selecting foot and leg protectors, it's important to ensure that they are suitable for the working environment, the type of work being performed, and the individual who will be using them. You can see the figures. Now I will explain more about it. Foot and leg protectors fall under different category classes. All equipment and accessories to protect the feet and legs and prevent slipping fall under category 2 class. Foot protector against static electricity fall under category 2 class. Because these equipments are used in environments with potential explosion risks. And foot protection for insulating against high voltage fall under category 3 class. For high temperature environments, 100 centigrade degree and minus 15 centigrade degree or lower, they fall under category 3 class, providing only limited protection against chemical or ionized radiation. The category is category 3. And for sports equipment, especially sports shoes, against minor impacts and vibrations that don't affect vital parts of the body and don't cause irreversible damage, fall under category 1 class. And the protection against normal or non-extreme weather condition in occupational use fall under category 1 class. There are standards related to foot and leg protectors. The TSEN ISO 20345 is for safety footwear and is indicated by S symbol. The TSEN ISO 20346 is for protective footwear. This is indicated for P symbols. These types of footwear include toe protection. There is another standard, TSEN ISO 20347 standard is for work footwear and it is indicated by O symbol and doesn't have toe protection. There is other standards. The TSEN 14404 is for knee protectors. And you can see the other standards. Safety footwear is footwear that is equipped with a toe cap, providing protection against an impact of 200 joule and a compression force of 15 kilonewton. We can see these design figures. A is for low shoe, B is for ankle boot. There are half knee boot, knee height boot, and thigh boot. According to the material used, class 1 is footwear made from leather or other materials, excluding footwear entirely composed of rubber or entirely composed of polymeric materials. Class 2 is for footwear, entirely made of rubber or entirely polymer based. The basic features related to safety footwear is the categories are shown here. For S1 is for closed seat region, anti-static properties, energy absorption of seat region, resistance to fuel oil. S2 is for S1 plus water penetration and absorption. S3 is for S1 plus penetration resistance plus cleated outsole. S4 is for closed seat region, anti-static properties, energy absorption of seat region, and so on. Meanings of marking symbols are shown on the table as you see. For type P marking, the feature is resistance to penetration. For type PL marking, resistance to non-metal penetration. C sign is for conductive footwear. A sign is for anti-static footwear. HI is for insulating against health. VR is for water resistance. AN is for ankle protection. CR is for cut resistance. CR is for slip resistance, and so on. And you can see the visualizations of protective footwear and work footwear. The first standard is for equipped with toe protection. You can see the figures. And the other one is without toe protection. Markings and information required on work safety shoes. The manufacturer should inform about size information, manufacturer's identification mark, design type, and the year of manufacture is important, and the 3-month production period is important. The relative standard should be stated. The symbols and categories suitable for protection should be stated. Now we come to the knee protectors. In cases where the ground is hard or there are objects such as stones that may penetrate the surface, knee protectors should be used. The relevant standard for knee protectors is TSEN 14404. Commonly used knee protectors include type 1, which are not integrated with clothing and can be attached to and removed from the knee. And type 2 is which are either inserted into a pocket located at the knee section of pants or integrated directly into the pants. Knee protectors are categorized into 3 groups based on their performance levels. Level 0 is designed for use only on flat surfaces and don't provide puncture resistance. Level 1 is suitable for use on both flat and uneven surfaces, offering a minimum puncture resistance of 100 Newton. Level 2 is suitable for use on both flat and uneven surfaces, providing a minimum puncture resistance of 250 Newton. For knee protectors in levels 1 and 2, the following requirements must be met. A pictogram indicating protection against mechanical risks must be placed on the product. Below, there is a pictogram. The protection level class 1 or 2 should be clearly indicated. As I finish my presentation, thank you for your attention. If you have any questions, I can answer them. You can say or write to the chat box. And here my email address. If you have any questions, you can ask via my email address. Thank you for listening to my presentation.
Thank you, Begüm Hanım, for your comprehensive presentation on personal protective equipment categorization. This has been quite fruitful for our participants. Dear participants, before we move on to the next session, we have got some time to receive questions. For those who have questions, you may write your questions in the chat box, or you may speak freely. In the meantime, I could also address that all these materials for these training sessions will be available very soon, and we will inform you as soon as the presentations are available. Thank you.
Thank you too.
We may wait for a couple of minutes more.
Thank you very much for listening to my presentation.
Yeah, the presentation was really amazing. And for me, coming back from a third world country like Sierra Leone, most of these PPE are not really available. And if they are in some places, some companies, they are substandard. And the health aspect of workers there, they are really being exposed to such harsh environment and health hazard because in terms of even the government, those who should monitor these organizations or companies, they are not even well equipped to go to these places, and it because of the bureaucratic nature of our system. And sometimes when someone wants to do their job diligently, and some of these companies, they just call the directors and then they tell them one of your boys or one of your staff is here harassing us, and then they just call you or come on, just we didn't ask you to go and do such, and so for us like developing nation, for me it's really challenging because the policies are there, but like the law is really not working. And that is why like the rate of accident in these workplaces and the health issues, it's really high. And to me, it's educating that I'm having this knowledge, like even having seminars after like the sessions, it's really difficult if you decide to have an event of such nature, there'll be no funding. And so lack of fund also is a problem to support such initiative to make it known to the general public, because without fund, you cannot do anything. And even like from those stakeholders, you try to call them for meetings and you try to share your ideas with them. They'll tell you there's no funding. And so straight off, your zeal, the energy you have, your knowledge, everything, they just destroy it from the ongoing before even you start to make a move. So it's really educative for me from a personal perspective. But like I said yesterday, from a national perspective, it's really difficult for developing nation. And me coming from one, I've experienced this. It's really hard. It's really hard. It's really difficult because they just give you anything that if you don't want the job, you can go home. And to get a job, it's really difficult. It's really like you have to know someone who knows someone. You have to be connected with someone. So getting a job, even when your health is being compromised, you cannot say anything. So this is a big challenge actually that developing nations are facing. So this is my input. It's really good. It's really educative, but from another perspective, it's really difficult for it to be applicable in places like where I'm coming from. So that's my contribution with regards to the presentation.
Yes, you are right.
Thank
I
you,
agree
Mr.
with you.
Aruna William. Thank you, sir, for your contributions for today's sessions. Dear participants, if there are no further questions, we may move on to the next session. So the personal protective equipment categorization session will be continued, and the next session will be brought to you by Miss Gül Erçoban. Miss Erçoban, if you are ready, we can continue with your session.
I am ready, Mr. Murat. I'm sharing my presentation.
We can
It's
see it on
okay.
full we can see it on full screen. There seems to be no problem. You may proceed, Nasip Hanım. Thank you for your collaborations once again.
You. Hello to all dear participants. Yesterday I had introduced myself. Today I want to introduce myself again. My name is Nasip Gül Erçoban. I am occupational health and safety expert and market surveillance inspector for 19 years in the institution in the market surveillance department. Today, I will give you a presentation about PP product groups. Mr. Begum told all of the product groups, and I will explain hand protectors and hearing protectors. First, I want to start with types of hand protectors. Types are defined according to the risks they use it. If we want to give example to them, protective gloves against mechanical risks, protective gloves against thermal risks, protective gloves against chemical risks and microorganisms, protective gloves against cold, and protective gloves against ionizing radiation and radioactive contamination. There are more risks at workplaces and more types of hand protectors. First, I want to explain the categorization of the gloves. The categorizations are defined according to the categorization guide. General gloves are classified as category 2. Gloves against high risks, such as electrical protection, heat protection above 100 centigrade degree, cold protection below -50 centigrade degree, and chemical protection are high risk, so they are classified as category 3. For low risks, such as weak cleaning chemicals, weak mechanic risks, they are classified as category 1. And we see on the market medical gloves, and they are in use at health sector. They are not PP. We don't inspect them. They are in scope of the responsibility of the Ministry of Health. Also, gloves for boxing. It is categorized according to its use. If it is used in the training and provide protection, it's category 1. If it's used in the match, they are not PP. And diving gloves are category 2. Here is the standards for gloves. Generally, for every risk type, there is a European standard. EN 420 protective gloves, and this is general standard for gloves. All gloves should provide the requirements in that standard. And EN 388 is protective gloves against mechanic risks. EN 374 and 1 is for chemical risks. EN 374 and 5 is for microorganisms. And EN 407 is for thermal risks. Here is more standards. EN 421 is for ionizing radiation and radioactive contamination. EN 511 is for cold protection. EN 659 is for firefighters. EN 12,477 is for welders. And EN 60,903 is for gloves against high voltage risks. I will give detailed information in future slides for some standards. First, I want to start with general requirements. As I said, all protective gloves should meet the requirements of this standard. It is EN 21000 and 420 standard. There are some requirements for all type of gloves. They are nickel relays for metal parts should be below 0.5 microgram per square centimeter. Gloves shouldn't contain any dangerous chemical substances such as heavy metals or carcinogenic products. The methyl formamide must be below 1000 milligram per kilogram. Polycyclic aromatic hydrocarbons must be below 1 milligram per kilogram. pH value must be between 3.5 and 9.5. For leather gloves, chrome content must be below 3 milligram per kilogram. Or allergic materials should be listed by the manufacturer in the user manual. Now we start gloves against specific risks. We start with gloves mechanical risks. Gloves against mechanic risks are the most products that we inspect on the market. We see the pictogram here. The standard is EN 388 as we see. I will open the this is the mechanical risk pictogram, and this is the standard EN 388. There are 5 values under the pictogram, and each value shows different criteria. First is for abrasion resistance. Second is for cut resistance. Third one is tear resistance. Fourth one is puncture resistance. And the last one is cut resistance. Second and fifth values are for cut resistance, but the methods are different. At second value, circular knife is used. At the last value, linear knife is used. Here is a sample of label of a glove. We can see the performance levels under the pictogram. We see 4, X, 4, 2, and B. There is an X letter here. X shows us that the glove has not been subjected to the test. We can say that this glove has not been subjected to the cut resistance test. And we see C mark, size, and pictogram. Here is the intervals of performance levels. First performance level was abrasion resistance, and it should be between level 1 or level 4. Second value, cut resistance, it should be between 1 or 5. Tear resistance should be 1 or 4 between. Puncture resistance should be 1 or 4. And last value, TDM cut resistance should be between A or F. A protective glove against mechanic risks must have at least a value of 1 from one of the abrasion, cuts, tear, or puncture values, or an A value from the TDM cut resistance. I will draw a pictogram here. From this definition, this is the pictogram. Sorry, pictogram should be like that. Under the pictogram, any value should be minimum 1. For example, like that. This is okay. We can say that this is a glove against mechanic risks, but this is not possible. This is not possible. And we see labels of some gloves. In the first example, it is again against mechanical risks. Abrasion resistance is 4, cuts is 1, tear and puncture resistances are 1. The standard is here, EN 388. Here is the brand and model of the glove. In the second picture, here is the brand and model of the glove and performance levels. Here is the standard EN 388. Here is the pictogram. We see values 4, X, 4, 3, and E. Last one is TDM cut resistance. First one is abrasion resistance. Abrasion resistance is 4. That means it provides the highest protection against abrasion. We see the CE mark, production date, and size. And this is the general standard that every glove should meet requirements, EN 21,420. And last one is, again, this is brand, model, standards, performance levels, and CE mark. These are examples for labels of mechanic gloves. We can see CE mark on each glove. We can see brand and models of the glove. Here is a glove against impact resistance. On the label of it, we can see the p-value. Here is the p-value. This letter shows us that the glove is against impact resistance. Sometimes we don't see anything on the glove as a 6th value. At that times, we can say that the product is not subjected to the impact test. Here is the protective gloves against chemical risks. The standard for chemical risks is 374 and 1. Protective gloves against chemical risks should meet the requirements of this standard. This is the general standard for chemical risks. According to the standard, there are 3 types: type A, type B, and type C. 4 types: permeability, performance value, and number of chemicals is important. For permeability performance, we see here, if the value is 2, that shows that the product, the measured breakthrough time is bigger than 30 minutes. If it's 1, that shows us the measured breakthrough time is bigger than 10. For type A gloves, that glove protects against 6 different chemicals. For type B, against 3 chemicals, and for type C, against 1 chemical. This is table 2. Table 2 shows us the chemicals. For type A chemicals, 6 chemicals from that list is for protection of that glove. Here is examples of the pictograms. This is the pictogram for chemical gloves. This is type A, this is type B, and this is type C. As we see previous table, type A protects against 6 chemicals, and we see the codes under the pictogram. Type B protects against 3 chemicals, we see the codes, and type C protects against 1 chemical. If the glove is tested against chemicals that is not listed in table 2, then this information shall be provided in the user instructions. And here's an example of label for a chemical glove. This is a type A glove. We can see the 6 chemicals here. This glove also protects against mechanic risks, and we see the mechanic performance levels under the pictogram. And we see C mark, and because this is a chemical glove, it's in high risk group, so it's category 3. So we see the notified body number next to the CE mark. Protective gloves against microorganisms. Here is the pictogram for microorganisms. If the glove protects user against only bacteria and fungi, this pictogram is used. If additionally virus protection is aimed, this pictogram should be used. Protective gloves against heat. Here is the pictogram for gloves against heat. First value shows the resistance to flammability. In other words, is burning behavior. Second value shows contact heat. Third is convection heat. Fourth is radiation heat. Fifth is small splashes of molten metal. And last one is large splashes of molten metal. For gloves against heat, there are 2 pictograms. One is this, and other is this. If limited flame spread is not claimed, second figure should be used. Limited flame spread is the first value under the pictogram. So here it has a value, it's 2, but if we don't need this performance level, this is X that shows glove is not tested for this value. And welding gloves. There is no special program for welding gloves, but a welding glove could protect against mechanical risks and thermal risks. So these 2 pictograms should be affixed on the welding glove together. Standard is different. Standard is EN 12477. Welding gloves classified in 2 groups, type A and type B. We see here, they are type A and type B. We can see the minimum performance values in the table. These are for EN 388 standard, and these are for EN 407 standard. These are mechanical risks, and these are thermal risks. They both standard performance levels should be used. Minimum performance values indicated in this table should be satisfied for each type. For example, if there is a type A glove, abrasion resistance should be 2, burning behavior should be 3, convection heat resistance should be 2. For type B glove, abrasion resistance should be minimum 1, and burning behavior should be minimum 2. Here we can see an example of label of a welding glove. We see mechanic risk pictogram, we see thermal risk pictogram, and we see mechanic standards, we see thermal risk standards, And there should be standard for welding gloves. It's 12,477. We see from here that it's a type B glove, and we see CE mark. We see the production date. This glove is not category 3, so we don't need notified body number. This is category 2 glove. Protective gloves against cold. This is the pictogram for cold. There are 3 values under it. First, convective cold, second, contact cold, and third, permeability to water. These are the other pictograms for hand protection. As we see, there are lots of risks at workplaces. One of them is gloves against radioactivity and ionizing radiation. One is for high voltage insulating gloves. The standard is 60,903, and this is the pictogram for insulating gloves. This is pictogram for electrostatic gloves, and this pictogram is for firefighters, and the standard is 659. Information is about hand protectors are completed. Now I will start hearing protectors. There are 3 types of hearing protectors that we inspect in the markets. They are earplugs, earmuffs attached to an industrial safety helmet. About categorizations, all hearing protectors are category 3. That means we should see the notified body number under the CE mark on the hearing protectors. Earplugs for swimmers to prevent water from entering the ear, they are not PPE, and they are not in scope of our inspections. While choosing the hearing protector at workplace, SNR value is taken into account. It is a signal noise ratio. SNR value should decrease the noise between 80 or 85 decibel dB. These are examples of the SNR value. As we see here, SNR value is 34 dB. Here, 33 dB. This value is important for hearing protectors. And if we look at the standards, EN 352 and 2 is for earplugs. EN 352 and 1 is for earmuffs. EN 352 and 3 is for earmuffs attached to an industrial safety helmet. Here is the examples of earplugs. These plugs are corded. These plugs are not corded. They both they can be used at workplace both. And this is a single box in a single box. These are not in a single box, as we see. They are all of them is okay for us. Earmuffs should be compatible with EN 352 and 1. As we can see here, these are the examples. And these are the earmuffs attached to an industrial safety helmet. The standard is EN 352 and 3. The hearing protectors use it with a safety helmet, as we see here. About marking, these are marking for all types of hearing protectors. First, name, trademark, or other identification of the manufacturer or his authorized representative information should be on the hearing protector or on the box or on the user instructions. Also, the number of the standard information, if it is single use or reusable. This is important for earplugs. Information of manufacturer on the box of earplug when earplugs are marked reusable. For custom molded earplugs and any earplugs with left-right orientation, a specific marking or color coding on each earplug to differentiate between left and right ear, manufacturing dates, and last date for use, month and year. SNR value, instructions for fitting and use, which shall indicate the need for proper fitting, size of protector. Also, there should be C mark on the earmuffs. For earplugs, C mark, they are very small, so C mark can be on the box of the product. Because it's category 3, notified body number should be on the product. Here is a box of the earplug. We see the brand here, and we see model here. It says it's corded. We see the standards. We see the C mark, and SNR value is 29 dB. This is a non-complying product because while beginning the presentation, I told that all hearing protectors are category 3. So notified body number should be under C mark, like that. 1, 2, 3, 4. There should be a notified body number. If we meet a product like that in the market, we should contact with the manufacturer and check for the certification. If the certification is not correct, we should take precautions for this kind of products. My presentation finished here. Thank you for listening, and you can contact with my email address. Thanks for again.
Thank you, Nasip Hanım, for your comprehensive and elaborate presentation. Dear participants, before we move on to next session, we may receive a couple of questions. For those who have questions, you may write your questions in the chat box or you may speak freely.
Introduced. My name is Rini from Indonesia. I have one question for PPE presentation here about the glove protection and others. My question is, did all PPE have expire date? Can you explain what the different glove or ear protection from the produce until the expire, how many time it will take the time? Thank you very much.
Thank you, Mrs. Rini Chris. According to the standards, we see generally there are a production date, maybe last date doesn't on the package of the product, but usage life should be indicated for ear protectors. there should be month and year on the product. And for gloves, the production date should be on the package. This is important for us also. This is important for users, but this is important also for us, for inspection personnel, because we take samples from the market and test it. We shouldn't take a product that the using date is finished. If it shows that if there is an expiry date and we take samples after that date, of course that glove will not be safe. The test results will not be safe. So these dates are important.
Thank you, Nasip Hanım, for your valuable answers for that question. Dear participants, for those who have questions, you may speak freely or you may write your questions in the chat box. If not, please.
One more. Thank you very much for the time. I mean, we have like safety helmet in the PPE, the expire that have written in there. So how we could know in glove or in hearing protection if the date will be written in there or not to expire that. Thank you very much.
For safety helmets, Mr. Erkan Serdar will give detailed information. But I can say that there should be a production date also on the helmet. Expiry date is responsibility of manufacturer if it is indicated in the user menu. Users should obey that date. The expiry date is mandatory or not is written generally in standard of each product.
Thank you.
Thank you.
Thank you, Nasip Hanım, once again. Seems like we do not have further questions. And Sardar Bey made a comment. Thank you for that. Nasip Hanım, can you see the chat box?
Yes, is there a question? Yes.
There's just one new question asked by Eko Ebango from Cameroon. Thank you for that. I could also speak the question.
Okay, please.
Hello, everyone. If I understand very well, the choice of equipment depends on the risks factors identified in the company. But I want to know who is supposed to control the quality inside the structure. Yesterday, somebody talked about the storage. I think it is important for all, even the employees, to be aware of the PPE quality. Thank you.
Yes, at workplace, manager is responsible for the storage and provide using the PPE for the workers for correct use, correct storage, and provide enough personal protective equipment. Also, safety experts controls it at workplaces. And workers should use the PPE correctly. Yes.
Thank you, Nasip
Is
Hanım.
it clear?
Yes. And Merve Hanım also made a comment for that. Thank you, Merve Hanım, for your valuable insights. Dear participants, now we can move on to our next session, PPE product groups, the third group. And the next session will be brought to you by Mr. Ömer Sert, Occupational Safety and Health Expert and Market Surveillance Inspector. Ömer Sert, if you are ready, we can see your presentation.
Thank you. First of all, am I loud and clear?
Yes, we can hear you loud and clear. No problem with that.
This is my presentation. Can you see my presentation?
We can see it.
Yes. All right then. Let me start with the introduction of myself. Good afternoon, dear colleagues, distinguished guests, and participants. My name is Ömer Sert. I've been working in the Ministry of Labor and Social Security for almost 14 years as occupational safety and health expert. Besides, I've been working in the head of Department for Market Surveillance for about 3 years. And my presentation will be about protective clothing and protection against drowning. Protective clothing is a kind of personal protective equipment. Protective clothing means all clothing, including clothing protecting against rain, which is intended to be worn by a person at work and which protects him against one or more risks to his health or safety. Whereas protective clothing will offer protection to different parts of the body. On the right, you see 3 kinds of laboratory coats. Next to them are 2 kinds of coveralls. Here on the left bottom, you see a chemical suit, high visible vest and jackets. Here. Right next to them are aprons and a full body suit. How do we understand which one provides what kind of and how much protection? This is what I will try to explain in this presentation, title by title and topic by topic. Our topic is personal protective equipment. As you may guess, usual worker uniforms are not considered PPE. Yesterday, Marwan also mentioned about exclusions, and I want to emphasize again. For example, on the right bottom, the shield and protective clothing on the policeman you see is not considered PPE. There is something right here. In this presentation, we will cover protective clothing, title by title, according to the hazards they provide protection against. Basically, types of protective clothing are high visibility clothing, secondly, clothing to protect against heat, flame, or cold, clothing to protect against electrical hazards, protective clothing against infective agents or biological hazards, protective clothing against chemicals. There are 5 types and standards. We will talk about them. Protective clothing against rays and radiation. Let's start with the general requirements, not the first one, but the general requirements. That's the corresponding standard is 13688, and it describes the general requirements for the clothing, protective clothing. First of all, yes, I mentioned that. For workers, it's important that they only use protective clothing that bears the CE marking. That's important. My friends colleagues also mentioned that today and yesterday. Protective clothing bearing the CE marking should include the information supplied by the manufacturer, as stated in this standard EN 13688, harmonized with the EU regulation. Any labeling used in the protective clothing should be legible, visible, permanent, and in the official language of the country of destination. Labeling of any kind of protective clothing should include name and address of the manufacturer, trademark, designation of the product type, commercial name or code, pictogram with size designation, identification of the specific product standard, pictograms, and levels of performance, only if required by a product standard, care labeling or qualification labeling, if protective clothing is disposable or intended to use once. Let me show you that. it has to be marked with the warning phrase "Do not reuse" or with the pictogram here. Gül Hanım also mentioned about the label. This is the general view of a label of a PPE and the clothing, protective clothing also. Let's start with the first one, high visibility clothing. High visibility clothing, or we may say reflective clothing, is worn to increase a person's visibility and therefore prevent accidents due to low eyesight. These clothing seriously increase attention, as we encounter a lot nowadays. As a result, it is often worn in occupations where hazardous situations are created by moving vehicles or low lighting conditions. Actually, and thankfully, they've been quite spread nowadays to most different kinds of workplaces. As you see in the slide, the three colors on the left conform to the related standard 20471. By the way, these are category 2. But the ones on the right, blue and the dark green ones, do not comply with 20471. Therefore, if encountered during market surveillance by us, of course, the manufacturer would be subject to administrative sanctions. Category number means, by the way, I want to remind the category number here. My friends, colleagues mentioned before also, but it's useful to remind that. Category number means degree of protection of the PPE that provides, while category 3 PPEs provide higher protection, category 1 PPEs provide lower protection. In other words, the higher the hazard danger, the higher and more hazard-specific protection is needed. You will also see CE marking in all my slides. Yesterday, Serdar Ertuğ Bey mentioned the meaning and the importance of CE marking. That's the indicator of the safety and the legal validation of the product. This is the description of the design of the high visibility clothing. In the standard, there is details related to design, quality, and classification of high visibility clothing. The design and quality of the material affects the classification of the product. There are classes. Class 1, Class 2, Class 3. On the left is Class 1, high visibility. In the middle is Class 2, high visibility. And on the right is Class 3 products. The visibility increases from left to right. On the right, highest visibility. Below are the related tables. The one on the left sets minimum requirements of materials for different areas for different classes. And on the right, the one on the right, this table, indicates the color scheme. Via this table, we understand that colors apart from yellowish and reddish orangish colors do not conform with the relevant standard. For example, if a blue vest is encountered on the market, we will impose an administrative sanction. Our second title is Clothing to Protect Against Heat and Flame. Under this title, we will also talk about protective clothing for use in welding. I want to start with this one. The requirements for protective clothing for use in the welding and allied processes are described in EN 11611. You see here, and you see the pictogram. The standard only focuses on protective clothing, hoods, aprons, sleeves, gaiters, and does not cover requirements for feet, hand, face, or eye protection used for welding. I want to repeat this part. This standard here focuses on only hoods, aprons, sleeves, and gaiters. Gaiters, hoods, something like that, sleeves, and gaiters. And does not cover requirements for hand, face, or eye protection used for welding. The protection clothing has to protect the welder against welding spatter, short contact time with flame, radiant heat from electric arc used in welding, besides allied processes mentioned in the standard here on the left bottom. So, besides, from the title of the standard, it states allied processes. What are these allied processes mentioned in the standard? The processes having similar types and levels of risk as cutting, arc air gouging, and spraying. There are different kinds of heat and flame hazards. Let's get onto the heat and flame protecting clothing. With different exposure levels and intensities, there are different kinds of hazards, different exposure levels and intensities. Which workers are exposed to heat and flame hazards mostly, do you think? Employees of ferrous and non-ferrous metallurgy, for example, and glassworks, as well as the ceramic industry, iron and steel industry, forges, foundries, welders, etc., are exposed to heat and flame hazards mostly. The correct selection of protective clothing against heat and flame hazards requires the determination of the severity of hazard at the workplace and the performance level of clothing. There are some details I want to mention very shortly. The protective properties and parameters of materials used for clothing against heat and flames. These parameters are determined by test methods mentioned in the standard. Each parameter is related to a relevant letter code. There are letter codes here. For example, for A1 or A2, limited flame spread is indicated with these code letters. Clothing material resistance to convective heat transfer from the flame is indicated with code letter B. Clothing material resistance to radiant heat is indicated with code letter C. Clothing material resistance to molten metal splash is molten metal splash is indicated with code letter D. Clothing material resistance to molten iron is indicated with code letter E. Let's repeat the important parts again. The clothing, protective clothing against heat and flame is described in this standard EN 11612, and protective clothing for use in welding and allied processes are described in the standard 11611, and the relevant pictograms are as you see here in the slide, on the slide. There is another type of protective clothing. This time this is against cold. It was heat and flame, and now against cold. This is an example of a clothing to protect against cold, as you see. These are trousers and jackets set designed to wear in cold workplaces such as warehouses in food industry, I guess. I encountered last summer in Istanbul during market surveillance. On the left, you see trousers and the jacket. On the right, you see the product with the instruction manual and pictogram. I took the photo. Left next to it is the photo of the label, photo of its label, which includes trademark. I didn't show the trademark. Model of the product. Pantolon means trousers. Under it, identification of the specific standard, which is, as you can read, I guess, EN 342. Under it, the pictogram indicating the protection against cold This is the pictogram, and this is the same. Under it, CE marking, and next to it, there is a value here. You can read, I guess. It's this is the insulation value. In other words, thermal resistance, which is stated as 0.456, as you see here, meter square Kelvin per watt. I mean, no, per watt. This states the thermal resistance value of the product. We can have a look at the table from standard right here to see the product's air velocity. Since the thermal resistance is 0.461, it should be near here. So the air velocity should be 0.4 meter per second and 3 meter per second, changing according to the hours, working hours. And I didn't mention this one. At the very bottom of the label, it states the origin of the product, made in Turkey, 2022, the date of manufacture. Lastly, at the top of the slide, there is a table from manual stating how much protection it will provide. Right here. It's over here. And it states stating how much protection it will provide in different cold temperatures according to activity level. As an example, if these trousers and jackets set can be worn at minus 37 degrees for 8 hours with middle activity. We can understand this from this table. Our third title is clothing to protect against electrical hazards. The corresponding standard is EN 61482. Sometimes you will see this IEC abbreviation, like a prefix of a standard number. I want to explain what is that. It means the abbreviation is International Electrotechnical Commission. I think this indicates the Commission made a good contribution to the preparation of the standard, or totally they prepared it, I don't know. You see two pictograms in the middle. The left was used before 2019 because the pictogram for electrical arc prevention was changed with the issue of the standard in September 2019. Electric shock and light emissions are not covered by this standard. More specifically, other effects than the thermal effects of an electric arc, like noise, light emissions, pressure rise, electric shock, the consequences of physical and mental shock or toxic influences are not covered by this standard. It's stated in the scope of this standard. In this standard, it is also stated that clothing against electric arc can have two protection classes according to their material quality and design. Class 1 represents a basic protection level. Class 2, an increased protection. On the right, you see an example of an electric safety suit. You may also encounter this kind of clothing on market as electric safety suits or arc flash suits. Our fourth title is Protective Clothing Against Biological Hazards, or by the exact name of the relevant standard, against infective agents. The standard is EN 14126. Performance requirements and test methods for protective clothing against infective agents is the exact name. On the right, you see a coverall supplied with respiratory protective equipment. Most of these coveralls are generally manufactured for single use. In other words, they are mostly disposable. As you know, we encountered these kinds of clothing during the pandemic a lot, especially on health service employees. Besides, lab workers and workers dealing with waste management may also use these kinds of clothing. These may also be found on market as biohazard suits or protective coveralls. On the right bottom of this standard number, you see the pictogram of the clothing against infective agents. These are also category 3, and CE marking should be on every PPE. So I put this CE marking on every slide of my presentation. All right. There are different types of protective clothing on market. Some coveralls, for instance, may be intended to use once, as I mentioned, and in other words, disposable. However, some suits may be not. In all conditions, the manufacturer should mention proper use and maintenance in instruction manual. On the right, you see a general model of a chemical suit, not a real product on market actually. What will determine the design and material of the protective clothing? That depends on how much protection is aimed and which corresponding standards are aimed for conformity. Here on the left, you see a chemical resistant coverall with the illustration of design by the manufacturer. The figure illustrates the different parts of the coverall and its structure and how it protects. And besides, we understand that it protects against broad range of acids and caustic chemicals. But exactly what kind of chemicals? To what degree of protection? Let's see the range of chemical protection and corresponding standard and pictograms. There are 5 different types of protective clothing against chemical hazards defined by standards in effect. On the left sketch, you see 3 types of clothing offering protection against liquid chemicals: type 3, type 4, and type 6. While one type against gaseous, type 1, and one type against solid chemicals, type 5. On the right side is a table I took from OSHA's website, which was last updated on December 2020. Nonetheless, the second row, type 2 here, air-fed non-gas tight suits are obsolete. The corresponding standard, EN 943, is amended in 2019, and there is no type 2 classification anymore. Type 1 is a gas tight suit, and the corresponding standard is EN 943. The full title is Protective Clothing Against Dangerous Solid, Liquid, and Gaseous Chemicals, including liquid and solid aerosols. Type 3 is liquid tight suit, and type 4 is spray tight suits. And the corresponding standard is 14605, protective clothing against liquid chemicals. Type 5 is suits against solid particles. The corresponding standard is EN 13982, protective clothing for use against solid particles. Type 6 corresponds to EN 13034, protective clothing against liquid chemicals. This type's difference is it offers limited protective performance against liquid chemicals. Minor, as it states here, minor splash of irritant chemical. Here are 3 examples for different types of chemical protection offering clothing. First one is gas tight suit, a very complex and well-designed preventive clothing. This is its pictogram and CE marking. Second one is similarly an example for both types 3 and 4, which offers protection against pressurized liquids and powerfully sprayed liquids. These are the pictograms. The last one here on the right is an example for type 5 and 6, which offers protection against solid particle and liquid splash. All of these clothing offers a significant protection. So all of them are category 3. And as I mentioned, all of them should have CE certificate and other documents, including test reports, etc., in order to validate their protection capability. This sentence is important. I want to repeat it. All of them should have CE certificate and other documents, including test reports, etc., in order to validate their protection capability. Let's move to our next title, protective clothing against rays and radiation. There are clothing preventing against X-rays and radiation. There are different kinds of hazards and different protection is required. The X-ray protecting clothing corresponding standard is EN 61331. The exact name is, as you see from the slide, protective devices against diagnostic medical X-radiation. Protective devices against diagnostic medical X-radiation. Part 3s are concerned. That is protective clothing, eyewear, and protective patient shields. There may be different types of clothing covering different parts of body, such as neck protection and hand protection. On the right, you see an example of a protective clothing against X-rays I encountered during market surveillance in Istanbul. Do you think this product is appropriate? Does it conform with the standard? Should we impose sanction? What are the most important violations, do you think, from the label, for example? Missings, for example. I talked about in every slide. I put something in every slide. Anyone want to answer the question by writing? CE marking is missing. CE marking is missing. Nobody answered. I will answer the question. There is no pictogram, for example. And there should also be trademark. And notified body number with 4 digits is also missing. So we, of course, imposed sanction for this product. My friend Yusuf imposed. Our next title, protective clothing against rays and radiation. The same title, but other subtitle, protective clothing against radiation, is described in the standard EN 1073. There are 2 parts. The full title is, as you see from here, let me show. Protective clothing against radioactive contamination. Requirements and test methods for 111. Part 1, ventilated. Part 2, non-ventilated protective clothing against particulate radioactive contamination. These products are also category 3, and CE marking should be on the label as always. On the very right, you can see an example of a ventilated radiation suit conforming to the standard, and left next to it is an example of a non-ventilated radiation suite comply with the first part of the standard. Lastly, we will mention about protection against drowning briefly. There are different types of equipments used against drowning. Type 1, flotation devices are life jackets, as you see on the slide. They are used in open waters where rescue efforts can take some time. Type 2 is a device as illustrated on the right. They are used in still waters offshore when a prompt rescue is likely. Type 3 is a kind of vest suitable for a variety of water sports, including rafting, as you know. Type 4 are kind of devices for throwing to someone not wearing like other categories. Type 5 for white water rafting, as you see here. They offer functionality and safety features. The corresponding standard is 12402, 402, and all of them are, of course, category 3. Our last slide. There are 10 parts of corresponding standard personal flotation devices, EN 12402. The part 1 is life jackets for seagoing ships, safety requirements for these devices. The part 2 and 3 and 4 are parts for different performance levels of life jackets. In part 5, standards for buoyancy aids are described. In part 6, special application life jackets and buoyancy aids are described. Part 7, materials and components. Part 8, accessories. And in part 9, evaluation is described. Lastly, how to choose the relevant personal flotation device is explained in part 10 of the corresponding standard. I want to thank you for your time and for your attention. If you have any question, I can answer. I will try to answer them.
Thank you, Ömer Bey, for your comprehensive and elaborative presentation on the subject matter. Before we move on, we could receive a couple of questions. Then we will have a 10-minute break. Dear participants, you may speak freely for those who have questions, or you may write your questions in the chat box. Our valuable speakers will be able to respond to them and answer them.
Yeah, Saha again, my contribution is the same like the first. Like the place I'm coming from, most of this protective you see, they are substandard. And the problem also lies with the government, the policies, like they don't check these things coming in because most of them are owned by government individuals, like who do business, like they go for substandard materials and just to make money at the expense of the health of their citizens or members of the society. So it's really a challenge that the policies are there and it's not working, and then people prioritize money at the expense of health of their nationals or people who work in these environment that have been exposed to such hazard environment. Example, like those who work in a electric department, you see them, the work, they are barely protected. Some of them didn't even have these protective gears. Also, the firefighters, they are being exposed to this hazard-like environment without proper gears. To me, it's good that I'm having this knowledge and that some of us are having this knowledge, but in practical, it's really difficult. It's really difficult because we may want to make a change, but it's really difficult because we are not actually at the apex of decision making and we cannot influence anything, even from an organizational perspective, because if you want to, and then you recommend these things to be bought, and when they go to the market, you know, they don't meet the quality standard that are there. They only meet substandards. So it has been a challenge over the years, and it's still been a challenge more with the inflation, which is like 50% inflation here. So things are really challenging to get someone to do this, and even those for themselves to get these protective gears. It's actually challenging because they are being underpaid, and when you are underpaid, it's really difficult for you to actually put some fund to get yourself these protective gears. So this is my contribution, and it's challenging for developing nation, and like Sierra Leone, where I am from, and it's good that I'm having this knowledge, and I'll keep on sharing it, just like the previous years. But like I said, it's really challenging. It's really challenging. So to me, I would be like asking if some of these invitations like will be sent to um, governments like ministers, those who are in charge of energy. Some of them should be part of these meetings we're having, these Zoom meetings, so that they can see the experience of what they're doing, that the hazard they're exposing their nationals to or their workers to at the expense of those who want to make money. Because we are here, but some of us are not actually at that apex of decision making. So you cannot say this to a minister. You cannot say this even like to your managing director or to your CEO. They'll ask you if you want to work. You just keep your mouth shut. But if you don't want to work, you keep like being a big mouth. Then we're gonna lay you off. So it's difficult. So this is really challenging for me, from the place of my where I'm working and from a national perspective as well, because of the economic crisis and all the other issues that comes with people from a developing nation.
Thank you, Mr. Arunabe, for your uh, valuable comprehension and contributions. Hey, participants, are there any other questions or contributions that you would like to make? If so, you may speak freely or you may write your questions in the chat box.
I think our contributor participant is an expert on site, right? Mr. William Saha. He's
Mr.
working on
Aruna
site.
William?
You are working on site, right? Uh, does he?
Yeah,
You are
I'm
working.
working. Yeah, I'm working at the Ministry of Technical and Higher Education, and
You are working in the ministry.
yeah, I work at the ministry as a human resource officer, and the welfare of staff is a key. But sometimes even like the buildings, okay, the structure is not really that it's
Construction. You are talking.
yeah, you go to this construction site, those who are like construction road workers, you see, they work them with substandard gears, and but there's nothing you can say from an individual perspective because when you say like you see people coming after you that oh you have a big mouth, you keep saying this. Okay, what can we do? Okay, if we keep talking, we're going to lose our job. We have families. Okay, we have to feed our family, and so it's a
So
challenge.
you are generally going on site to workplaces and facing these kind of problems.
Yeah,
Sorry to
yeah,
interrupt.
yeah.
I want to,
Yeah, on
the,
site
the
also.
situation is not that much different in other countries and in our country. This is a process. I think is a culture. This occupational safety and health is a culture, and the education is very important. It will this culture will increase in time, in a long time maybe, but it will increase in time. That's
Yeah, I
my.
know. Yeah, I know. I'm hoping for the
We will
better.
try. Yes, we will try to
Yeah,
increase awareness.
yeah. I'm hoping for the better, like I said, but when the economy like keep like shambling and then the inflation keep going up, then it becomes another whole different paradigm shift about how much can I spend to get these gears and how much will it cost me? And you look at my job, how much am I earning? Like back home, like people are living below or $100 a month. Most
Yes.
people they pay them less than $100 a month. So it's really difficult to get quality standard gears
All
in
right.
any place of work for an individual. So if the organization or the institution or the firm you work in cannot provide you, you compromise in your health.
I want to add about Mr. Arunas's comments. In Turkey, we follow a policy. Preventing is cheaper than paying. We should follow this policy, and first of all, we should believe this policy, and our employers should believe this policy.
Thank you, Nasip Hanım.
Preventing is cheaper than paying. Thank you.
Preventing is cheaper than paying. Also correct. And thank you, Ömer Bey, for your valuable insights. Also, a comment made by Rashid Husseino from Azerbaijan. I would like to speak that as well. I believe that the protective clothing you described is fully comprehensive. However, in the modern world, professions have emerged that require protective clothing against falls, slips, and impacts. Let's take Yunus police officers, for example. They are at work doing their job. They also need protection that can prevent bone breakage and protect the body during a fall. Perhaps this area is not so relevant now. I hope that attention will be paid to this in the future. Thank you. Ömer Bey, would you like to give a contribution for this?
Yes, I mentioned in one slide that actually it's in the beginning. I mentioned that police and gendarme, the uniform, the equipment they wear are not covered and not considered as PPE. But you're right, this is important. Their safety is important. They can select the corresponding equipment, protective clothing, according to the hazards they face. They may use the standards and safe occupational safety and health procedures, instructions. They can get help from this side, and they should also use these kind of equipments. But as far as I know, their equipments are specially manufactured. A specific manufacturer is in question for their equipments. So the
Also,
institution is actually, for example, for police head of department for police is responsible for the equipment, the quality of the equipment, and the protection level of the equipment. Answer is enough? I don't know, but sufficient.
in the
My answer is sufficient, satisfying. Is my answer.
we believe it was, Mr. Ömer. And in the meantime, Rashid Bey also added some comments. I'm speaking that. This also, just a sec. This also applies to workplaces where workers used on motorized mechanisms, such as Ministry of Emergency Situations, ambulances on two wheels, and couriers. For further addings. There's a question apart from this conversation asked by Mr. Alexis Banhort. Are these colors for each personal protective equipment depending on the activities?
No, actually. It's the choice of the employer and the employees. For example, we see generally greenish or yellowish vests, high visibility vests on construction workers, but that totally depends on the choice of employer or the employees.
Okay, thank you, Ömer Bey. The last question asked by Mr. Soha Ali Yusuf from Sudan. Thank you for the presentation. Kindly can you elaborate about waste management for the PPE that for one use?
And if you want or should say, share my slide again. For example, I mentioned about waste management in biological hazards in the title biological hazard. Let me have a look at that. This it should be that there are disposable, coveralls that can be used in waste management, in solid waste, and this waste management. Which one do you say waste management when you say waste management? Waste, solid waste, does it, or chemical waste, or biological waste? There's different kinds of wastes. Can you write down, please? For example, wastewater is also waste management. The hazards may differ according to the wastes. Which kind of waste? For
I
example,
think
if it's health.
for PP, that for wine use. For example, wine use coveralls,
Yes.
coverall clothes.
Yes.
Maybe it can be disposed into special boxes for chemicals and biological clothes.
Let's say yes. Let's say if it's a solid waste management and there are chemicals, hazardous chemicals, you should use you should choose the protective clothing against chemicals. For example, if there is a very hazardous gas, for example, you should choose type 1 gas tight suit. For example, if you are working in wastewater management facility in a factory, the hazards are not that much dangerous, so you can use type 5 or 6. For example, if you're working in a hospital, if a worker and he's dealing with solid waste management, the waste for medical waste, for example, he's dealing with medical waste, then you should choose biological hazard, the protective clothing against biological hazards. Some clothing may include both chemical and both biological protection. That depends. The choice depends on the employer and the employee and the cost of the personal protective. Yes, the answer is sufficient?
Also, thank you Ömer Bey. Gonca Bayraktar Hanım also made a comment for that question, so thank you for that. And yes. Dear participants, we now are making a 10-minute break. We will return at 10 past 12. Thank you for that. Okay. We will be back in 10 minutes. Thank you. Dear participants, I believe we can continue where we left off. For the next session, PPE product groups, the fourth session, will be brought to you by Mr. Erkan Serdar Sertar from the Ministry of Labor and Social Security of the Republic of Turkey. Erkan Bey, welcome, sir. On behalf of SESTRIC, we would like to welcome you for this training session. If your presentation is ready, you can share it.
Okay.
We can
Yes.
see your presentation, Erkan Bey. The floor is yours. Thank you so much for your collaborations.
Thank you very much, Mr. Murat. Hello to all dear participants. Merhaba from Turkey. Today I will give you a presentation about three PPE groups, product groups. One of them is PPE against fall from height, and the second one is head protective equipments, and the third one is eye protectors. My name is Erkan Serdar Sertar. I am an occupational health and safety expert and also a market surveillance inspector in the Ministry of Labor and Social Security for 12 years. And my first presentation is about PPE against fall from height. And also I will mention about the related standards. Yes, it's better. Yes. The types of fall from height equipments are here, as you see: full body harnesses, working positioning belt, lanyard, retractable fall arrestor, energy absorber, and carbine connectors, we can say. These are category 3 equipments because these are high risk group. And the related standards are those TSN 354 connecting device carabine, and this TSN 355 energy absorbers, 358 belts and ropes for working, 360 retractable fall arrestor, and 361 is full body harness systems. Mostly we see this standard at this type of equipment in the sector, and 362 carbines and 364 experimental methods for tests, and 365 general use, for use, maintenance, periodic inspection. Let's start with full body harness. This distributes the force of a fall over the shoulders, hips, and pelvis. Here, let me do laser. Shoulders. If there is a fall, the shoulders and hips and the legs, the pelvis. This is the most effective stop type of fall, and the standard is, as I mentioned, TSN 361 and 358. This with this is the same, but this is also with waist support here for working and positioning. Here, as you see, working position, fastening device here, and marking for fastening device. This is for fastening to the life. You see lifelines. You can say it prevents the person from taking a position where a fall may occur. Here, working positioning belt. This is only working position belt, not full body harness. This is this is used for only positioning. And the important point is this doesn't stop the fall. It's for positioning and limiting purposes. It's used for this. And the related standard is TS and 358. And this should not be used alone in the above in the height because this is only for positioning, not life, not protective. And the energy absorber is a piece of equipment used in fall arrest systems designed to absorb the kinetic energy generated during a fall. And the standard for this is 355. And mostly this is used with lanyard. I will mention about lanyard in the presentation. This slow down your fall. Only works for that. Retractable fall arrestor is a personal protective equipment with self-locking function and retractable fastening device. Firstly, locking function stops your fall, and then you retract the previous position. And standard is TSN 360. These are different types here. Mounting device lanyard is equipment that connects the full body belt and the connection point. This is a connector type, and the standard is 354. And the material is, there are different material types used in this equipment: synthetic fiber rope, wire rope, braid, or chain. And the types: single arm, double arm, hooked, length adjustable, or flexible types we can see. For example, double arm lanyard here. These are lanyard double arm, and this energy absorber here, and this is carabin. Used in situations where there is more than one lifeline and workers are passing between these lifelines, or when working on fixed ladders. And lanyard and energy absorber can be used together, and the standard is 354 and 355. And this must be available on the product separately because these are different. And the carabiners, connectors, in other words, carabine are deployable devices used to connect the user directly or indirectly to an anchor. Classes are as shown here: B class as the type figure you see, T class here, and A class here, and the Q class here. And the related standard is 362. Important point for the connectors is they should not have sharp edges or burrs, and they should be corrosion resistant because these are metal parts. And the other slides, now head protective. Let me share it.
Thank you, Erkan Bey,
Yes.
for your
Yes.
presentation.
No, I'm continuing.
Oh,
Second one.
sorry.
Three different presentation I have.
Okay. Okay. Please go ahead.
Yes. This head protective equipment. Firstly, content, science and information, and standards, and the compulsory and optional features. I will mention about those today. Helmet. And the science and information that must be on helmets. First of all, standard number should be written on the equipment. For example, TS.
Mr. Arkan, we can see the new presentation.
Shall I?
Ah, yes.
Okay. Let me share again. Is it okay? Can you see?
Yes, we can see it now.
Yes. First slide is that you see helmet, and the second one is first of all, standard number should be written on the equipment. For example, TSN 397 is standard number for used for helmets, industrial safety helmets. And category 2 and category 3 we see in this equipments. It changes. I will mention about that later. And second, manufacturer's name or logo, as you guess. And the third one, year of production and 3-month period, as you see in the figure here. There are different types of signing. This production date, this is one of them. Basically, main sign type is like this. And another information on helmets is its size information, measurement. To ensure adequate protection, this impact headgear must be adjusted to the user's head size and fit snugly. No paint solvents, adhesive or self-adhesive labels should be used, except in accordance with the manufacturer's instructions. And the last one, body material, ABS, HDPE, ABS is acrylamide butadiene and HDPE high density polyethylene and LDPE low density polyethylene and polyamide are different body material types. Here you see an marking here CE. Let me yes. Here CE, EN 397 and LD, MM. I will mention about this optional category. And here the production date, for example, and this measurement. Measurement is important for the head, to fit a head. And standards, use the standard numbers. And for example, this common one, TSN 397, industrial safety elements, and the other types, TSN 443, protective headgear for fighting, for firefighting in buildings and other structure. And for example, TSN 812, headgear used against impact industry. Impact caps, this is small ones for only impact. And TSN 14,052 high performance industrial helmets is different one, and the TSN 50,365 electrically insulating caps for use in low voltage installations, and anti-static helmet is 300 sorry, TSN 1000 no, it's 1127 you can say. And lightweight helmets designed in manufacturers to protect the scalp against small impacts whose effects cannot cause irreversible tissue damage. The other type. And let's talk about compulsory and optional features of industrial safety helmets. The compulsory features, shock absorption, puncture resistance, flame resistance, and chin bend. And its optional features is very low temperature, very high temperature, electrical properties, lateral deformation, LD, and molten metal splash, MM. This is for industrial safety helmets. And the industrial impact cap, as you see here, impact cap, standard is 812. Impact protection, puncture resistance, and chin bands, compulsory, is the same with the helmet. And only shock absorption, you cannot see here shock absorption. And optional features, very low temperature, electrical insulation, and flame resistance. Symbol is F for this. And industrial impact cap is defined as helmet designed to protect users' head against injuries that may occur as a result of hitting fixed hard objects. Cap impact helmet. Since it technically does not provide the level of protection that a helmet has, it cannot use instead of a helmet. This equipment must comply with the TSN 812 standard. Heads and helmets will not be used because they do not provide sufficient security against materials that may fall. They are used in construction work, especially work done on, under, or near scaffolding and high-altitude working platforms, mold making, dismantling, assembly, and installation work on scaffolding and demolition works. If there is a chemical exposure, there should be no ventilation holes in environments where fresh air can enter from lower edge of the helmet and exit from the upper holes. And there should be a sweat band, but not mandatory. These are optional, another optional specialties. Compulsory features here for the tests of impact resistance, puncture resistance, flame resistance, and the resistance of the chin strap connections should be between 150 Newton and 250 Newton for chin strap. In impact resistance, this test with a 5 kilogram mass fall from 1 meter above here. Puncture resistance test is done 3 kilogram pointed mass here from 1 meter above, and the flame resistance test is it must withstand continuous flame for 10 seconds. And chin strap connection must have the strength above 150 Newton and below 250 to prevent the helmet from coming off easily. However, in case of tripping or similar situations, in order to prevent a person from having their throat cut or not being able to breathe due to the chin strap, they must be designed to break and release the chin strap above the certain force, 250 Newton. In order not to put the head or neck at risk in the event of impact, they must be elastic, or the strap must be detached from the helmet according to the severity of the impact. They mustn't cause neck or jaw fractures or difficult breathing. It's an important point for the chin strap. Optional features provided must be indicated on the helmet and the following markings. Very low temperature, it's 20 centigrade degrees or minus 20 or minus 30 centigrade degrees. These are category 2. And very high temperature, over 150 centigrade degrees are category 3. Lateral deformation, LD, and molten metal splash, MM, and electric characteristics, 440 volt alternative current, and here electric characteristics, and that provide electric features. The leakage current should be less than 1.2 milliampere in case of voltage contact at certain points. This feature is intended to protect the helmet user in case of short-term accidental contact with an electrical conductor in work environments where they are dangerous from low voltage electricity. This type of helmets should have the phrase 440 volt alternative current here. And electrical insulated helmets are used for works performed under loads with voltages not exceeding 1000 volt alternating current or 1500 volt direct current according to standard number EN 50365. This is category 2, 3. This is category 2 and this is category 3 electrical. Only very low temperature is category 2. And optional features, lateral deformation, LD, there should be a maximum of 40 millimeter collapse as a result of compression from the sides, and permanent deformation after compression should be a maximum of 15 millimeters. And the molten metal splash and no burning should be observed for 5 seconds after the metal is poured and used in casting sector. Yes. And the third slide about eye protection. Okay, see. Can you see?
Not at the moment, Erkan Bey. We see the presentations.
Yes,
Yeah.
yes, now.
Now
Okay.
it's working.
Okay. And the contents for eye protectives, identification, related standards, and types and categorization, specifications and marking, and examples of marking. Let me pointer. Yes. Eye and face protective equipment are used to protect the face and eyes against factors and risk factors such as molten metals and hot solids, droplets, and splashes, dust, gases, electric arcs, ionizing radiations, and impacts of various intensities and optical radiation in the work environment. These are the related standard numbers with eye protection. For example, general requirements is 16,321, and this is for 1 general requirements, 2 is additional requirements, and 3 is for mesh type protectors, and these are related techniques during welding, and 12,311 is personal eye protection and test methods for sunglasses and similar, and 12,312 one, and I am face protection, sunglasses, and general use. These are the standards we use. And general use glasses is here, as you see, this is general. And full protection, goggles here, as you see. And the glass for welding is used for welding, and the visors here. General category is 2, but eye protectors and filters designed and manufactured for use in high temperature environments whose effect can be compared to air temperatures of 100 centigrade degrees or more, characterized or not by the presence of infrared radiation, flames, hot material splash, or large amounts of molten material. Eye protectors and filters designed and manufactured to provide protection against ionizing radiation, and eye protectors and filters designed and manufactured to provide against electrical risks are category 3. These are category 3. If you see these protective types, these are category 3. And also swimming and diving goggles and masks, and eye protectors and filters designed and manufactured solely to protect against sunlight, sunglasses for private or professional use, and all types of ski goggles, these are category 1. And marking and specifications. Marking of eye protectors must be clear, permanent, and visible. They must not violate or obstruct the field of vision. One of the specification is this. And the frame and eyepiece. What's the frame and eyepiece? The light transmitting part of The eye protectors such as lens, viewfinder, shield made of cage, glass or plastic material that allows vision must be marked separately. If the eyepiece and frame are single piece, the frame must be marked completely. And this is an example of marking eye protector. Here, you see. This is, for example, production date, conformity mark, CE, additional marking here, mechanical strength here, and the other one I will mention about later, those. And the requirements, standard sign here, 16,321. Manufacturer's identification mark here, UV ultraviolet filter here, U1, 2, U5. Detection of UV filter here, infrared filter here, R. Detection of IR infrared filter signal size here, RL. And IR infrared filter enhanced reflection, RR. Infrared filter signal light perception and improved reflection, RRL here. You see sunlight filter, G. Detection of daylight filter signal lights, GL. As you see here, codes of letters and code numbers. And the other one, glass blowing, SF1, shock level, CDE, effect level, HM, and shock level, extreme temperature, it's 45 meter per second, for example, CT, 80 DT, and the E for 120, and shock level, extreme temperature, HMT, head size, body marking here, you see head size. Enhanced optic performance optional, this is optional specification. 1, droplets, large dust particles. 4, if you see 4, for example, on marking of a eye protector, you will understand large, it's protect you for large dust particles. This means those liquid flows, resistance fogging, chemical resistance, molten metals, 9, for example, radiant heat, 7. And this example of ultraviolet protective eyewear marking is, you see something like this. The standard number is, and the manufacturer's designation symbol, for example, producer symbol, or U2 is ultraviolet filter or color symbol, D for impact level, 3 for symbol for droplet protection, CH for chemical resistance. And face shield marking example is here. Again, standard number, manufacturer's designation, symbol for impact level, C, liquid flow, for example, 6, and for molten metals and hot solids is 9 here. And this is all for my presentation. Thank you very much for listening to me.
Thank you, Erkan Bey. I believe this was your latest presentation, right?
Yes, yes, yes. I finished.
Okay, thank you so much for that. We have got limited time for questions. Dear participants, for those who have questions, we would like to ask your questions in the chat box. We can wait just a couple of minutes because we are behind the schedule.
Okay for me to speak, or I write in the chat?
Mr.
Can you
Ambrose,
write?
Yes, this is Mr. Ambrose. It's a quick one, really. Mr.
we
Khan, I
are
would like to talk to you
sorry,
and,
sir, we are not able to receive your voice. Can you write your question if it is possible?
okay,
Yes.
okay.
Thank you for that. In the meantime, Ali Burak Bey, would you be able to open your presentation so that we can save some time?
Yes, I can.
Erkan Bey, can you see the questions in the chat box? Or would you like
Yes,
me to
yes.
help you?
Sent to,
Okay.
yes. I see. Thanks for presentation. What's your take on the color of PPE a helmet is a part of your standard, or do you leave it for enterprise administration to manage? Some companies to go different color of helmets, reflector jackets. Yes, there are different colors. There is no color choice for in standards. Different producers use different colors.
Thank you, Erkan Bey, for your valuable answers. Dear participants, if there are no further questions, we will have to continue with the latest session of today's training course. And this will be brought to you by Mr. Ali Burak Özdemir. Thank you, sir, for your kind presentation. The floor is yours. Thank you for that.
Thank you for participation. Sorry about the camera. My name is Ali Burak Özdemir. I am an occupational health and safety expert in Institute for 10 years. I would like to inform you about PP tests in our laboratory. First, our laboratory established in 2012 with the scope of European Union project for the purpose of the strengthening the personal protective equipment market surveillance. We test samples taken by the market surveillance inspectors, sent by PP manufacturers, PP purchasing agents from companies, samples from the other government institutes, samples from the labor courts. We can test in our laboratory PPE against fall from height, gloves protecting against mechanical risks, food protection, PPE, personal life protection, head protection, and some of protective clothes. When a sample comes our laboratory, first off, we classify the samples and label it and prepare and test. How we prepare? We cut, we wash, we condition, we age the samples according the standards, test standards. First off, eye protective equipments and hence durability testing for eye protection. We perform the test according to TSN 168. We measure the strength of eye protection. The other slide is a small, short video about the test.
Burak Bey, there seems to be a problem regarding the video. It's not working. Now it's working.
Is there a voice in the video? I can't hear from my earrings.
There's no voice for the video,
Okay.
but that may be a malfunction for the program.
Okay. I can pass the video. The second test is head protection. We perform the test according to TSN 398 and 97. There is a video about the test again. The machine measures the impact of the helmet and show us the result. The other test is the puncture protection for head protective equipment. We perform the test according to TSN 397 again, and the video is here. The same device, but the testing head is changed. The other tests are footwear protection equipment tests, impact resistance code for footwear protective equipment. We perform the test according to TSN 20-130-45. We measure the resistance to impacts on the toe and the shoe. Here's the video of test. First, we cut the shoe, footwear. Let me do. Technical problem about the voices.
Yes, regarding the voice, when you're sharing the videos, there might be two options. Mr. Brock?
Yes.
While you
Yeah,
share, you know, there might be two options. You will be selecting the two options. You know, when you are sharing your screen, there you can see two options.
Okay.
One will be related to the sound, one will be related to the, you know, the presentation. If you select both of them, we can hear you the voice.
Okay. Sorry about it. And now, okay.
Now it's okay.
Shall we watch the video? The first video of. Do you want that?
If you want, you can share it. No problem.
Okay. Okay.
Okay.
I am sorry about that.
No, it's okay. No problem.
The eye protector that will undergo testing is positioned normally on the test head. Carbon paper is placed under the test head of the eye protector. The test head and eye protector assembly are positioned in the test setup. The holder where the steel ball will be placed is ready. The ball drops on the points. Eye protectors must resist front and side impacts.
The other test.
Barrett items. It is placed on the head mold as it would be worn, ensuring the gap between the mold and the barrett is minimal. Through a computer program integrated with the device, the peak of the barrett is accessed. A mass weighing 5 kilograms is dropped from a height of 1000 millimeters plus or minus 5 millimeters to conduct the test. The force transmitted to the cap mold is read through the computer program and the test result is evaluated. To pass the test, the maximum force on the head mold should not go over 5,000 newtons.
Other video.
The Barrett samples are placed on the head mold as they would be worn on the head, ensuring the gap between the Barrett and the mold is minimal. A computer program integrated with the device measures the Barrett's peak at 1,000 millimeters plus or minus 5 millimeters. The test is performed by dropping a mass weighing 3 kilograms. The impact point must be inside a circle of 50 millimeters radius at the Barrett's top. The head mold must be adjusted as needed according to the Barrett's impact point. To pass the test, the dropped mass must not touch the head mold, and the mold's contact surface should show no visible damage. No damage should be visible. The device detects contact between the head mold and the mass through a signal sound. The purpose of this test is to evaluate how well toe caps made of steel or composite withstand impacts. The test is performed based on the TESEN ISO 2344 standard. The protective toe cap needs to be severed for the test. For this, a sample marked 3 centimeters from the end of the protective toe cap is completely separated using strip tests. The cut toe cap section is prepared with clay dough, shaped to a specific height and cylindrical form based on the type of toe cap. The toe cap section is fixed in cylindrical dough with a clamp to test its impact resistance. It's in the test device. Then, the protective glass area is sealed and the device is turned on to apply the impact head to the sample face or both sides based on the foot protector. It's set for application. The test impact mass is applied to fall freely onto the sample. After testing, the sample is removed. First, it is visually checked whether there is any breakage in the sample. Then, using a caliper or similar measuring tool, the height is determined from the deformed part of the dough. This height is compared with the minimum values for suitability based on shoe size and type. It is compared with the minimum suitability values specified in the standard.
The second foot protection equipment test is electrical resistance for footwear protective equipment. We perform the test according to TSN 20345. We measure electrical resistance of a footwear on dry and wet conditions. Here is test video.
A test is performed to assess the suitability of anti-static and conductive foot protectors based on TSN ISO 2344 standards. A copper plate is used to hold the sample. A total of 4 kilograms of balls are poured into the sample. There are 2 electrode tips in the measuring device. One electrode is connected to a rectangular copper plate and submerged in the steel balls. The other end connects to the copper plate, finishing the circuit. Device on. For 1 minute, a 100-volt electric current is applied to the foot protector with a timer. After 1 minute, the resistance value in ohms created in the foot protector is noted. The resistance value is evaluated to see if it falls within the desired range according to TSE, ENE, ISO, and 234 standards. If the resistance is within the acceptable range, the sample is deemed TSE compliant.
Here is a gloves protecting against mechanical risks. The first test is abrasion test, abrasion resistance test for gloves. We perform the test according to TSN 388. Here is the test video.
The abrasion resistance test for protective gloves determines their lifespan and safety against mechanical risks. In our laboratory, the abrasion resistance test is conducted according to the TS-EN 388 standard. 4 samples, each with a diameter of 38.5 millimeters, are taken from the same production series and model of the glint at a Celsius with 5 at least hours. The samples go onto the carrier. 9 kilograms of pressure will be applied to the samples, positioned symmetrically. The device is set up and the test starts. At 500, 2000 and 8000 revolutions, the samples are checked. Wear on the sample is visually inspected to see if it has worn at least 2 millimeters from the corners.
Second glove protective test is tearing resistance for gloves. We perform the test according to TSN 388 again, and here is the video.
The tear resistance test for protective gloves covers the testing method for their tear properties. Test. The test is performed based on TSE, Standard 3886, clause. Unless stated otherwise, all samples are taken from the glove's cuffs for classification. Before testing, samples are conditioned in a chamber for 24 hours at 23 plus or minus 2 degrees Celsius and 50 plus 5% humidity. They are kept at 50% humidity plus 5. Once the 24 hours of conditioning are complete, samples are removed from the chamber for testing. Every strip cut beforehand should be at least 20 millimeters long, aligned with the sample's length. Chins spaced at least 10 millimeters apart are clamped to the stretching test apparatus. The uncut end of the test sample is released. The software starts the test. The test lasts until the samples tear. The software provides the highest resistance force of the sample as its buckling strength value. The lowest result obtained from the 4 samples is recorded as the test result.
The last test is the puncture resistance test for gloves.
The test for the puncture resistance of protective gloves covers the experimental method for gloves against puncture risks. Test. The test is performed based on the 5 criteria of the TSN the Threed XXX, Threed standard. Unless specified, all samples are collected from the glove settings for classification. Samples should be round and have a diameter of at least 40 millimeters. Before testing, samples are conditioned in a chamber for 24 hours at 23 plus or minus 2 degrees Celsius. Humidity is kept at 50% plus or minus 5. After the 24-hour conditioning period, samples are removed from the conditioning chamber for testing. Samples are placed centrally in the testing device with the outer surface facing the needle. Testing starts with the software tool. The needle moves downward on the sample. The needle moves at a speed of 100 millimeters per minute, shifting up to 50 millimeters unless the sample is punctured. The software provides the highest resistance force of the sample as its puncture resistance value. The lowest result obtained from the 4 samples is recorded as the test result.
Last test we perform in our laboratory is dynamic performance test of full body harness. We perform the test according to TSN 364.
The tests for fall protection devices are performed in accordance with TSN N364 and TSE EN361 standards. The ability of the mannequin body to be released is evaluated considering the D-ring and textile characteristics. The full body harness is secured by dressing the mannequin. The mannequin's head is positioned upwards and connected to the anchor point with a climbing rope when it is 2 meters long. The anchor point is raised to a maximum of 300 millimeters vertically above 2 meters. The experiment area is cleared and the operation room is entered. The mannequin is let go from 4 meters high with no initial velocity. According to TSEN 364, the full body strap must not drop the mannequin. The D-ring can't break. The buckle tongues and fastening devices must not break. Textiles can't break.
Thank you for listening my presentation. The QR code is our YouTube channel. There is more contact in there. If you want, you can scan the QR code. For your questions, all the tests are performed by different experts. They are my colleagues. You can mail me and I will back to you. Here's QR code. Thank you for listening.
Thank you, Ali Bey, for your comprehensive and fruitful presentation and videos. There is one question asked to you by Mr. Ambrose. How is it funded? Does it get funded by purely on the government, or does private sectors directly contribute to certain statutory fees? Can you answer that?
Our laboratory is tied to the institute, tied to the IO minister by government also, funded by government.
All right. Thank you, Ali Bey, for your answer. Dear participants, are there any further questions? You may write your questions in the chat box. If there are no further questions, we can close today's sessions with closing remarks. We will share all the presentations, all the course materials very soon. We will inform you through emails. If there are no further questions, we can close today's session. For the closing remarks, Aliye Hanım will deliver the closing remarks. Aliye Hanım, the floor is yours. Thank you for this.
Yes, thank you very much, Mr. Murat. Yes, dear participants, it is not like formal closing remarks. Just I would like to thank you all Alhamdulillah, we have come to the end of this training courses. First of all, as CISRIC, we would like to express our sincere gratitude and appreciation to all of you for sparing your valuable time for past 2 days. And we would like to congratulate all of you successfully completing and contributing this training course. Especially to the Directorate General of Occupational Safety and Health of Turkey, DEGOSH, and their distinguished speakers, namely Ms. Nasib Gul Archoban, Mr. Aykut Karakavak, Ms. Marwa Koyucu, Mr. Sardar Ertush, Ms. Begum Selsupur, Mr. Omar Saad, Mr. Arkan Sardar Sartar, Mr. Ali Brok Özdemir, for their valuable effort, facilitation, and insightful presentation, as well as the contribution of all participants who have made this training course active and productive. Before concluding, I would like to state that CISRIC will further continue its collective effort and support towards enhancing the technical capacities of member countries through any of its mandated means, as well as its capacity building activities, including we have this OIC, Occupational Safety Health Network, or short name OIC OSHNET, and Occupational Safety Health Capacity Building Program, OSHCAP. Thank you all once again for connecting with us from 28 OIC member countries all over the globe. I wish you all of you a nice day. Wassalamu alaikum wa rahmatullahi wa barakatuh.
Thank you, Aliye Hanım. Dear participants, we would like to thank you for your active participation for the training courses. For the upcoming activities, we will inform you, and thank you for this.
Thank you. Have a nice day, all of you.
Thank you very much.
Have a nice day, and thank you.
Thank you too.
Very much.